As we're going through this, I just want to emphasize really strongly that with annuities and this whole financial mathematics series topic, that no question really is going to be the same. There will be similar aspects and elements, right? There will be stuff where we're adding money, or there's stuff that we're withdrawing money, or sometimes both. But the way they craft the questions, though, are always typically very different, which makes things difficult, right? As long as we are thinking about the core aspects of this, of how these series build up, then that makes these questions much more approachable. Can I get the initial information that we've got? How much money are we starting with? What's happening here? We're starting with $1 million. So what's the situation? Have we reached the end and we're like we're withdrawing money or something? Is that what's going on? Or want a competition, okay? And they want to invest the money, but also they want to like start taking money out as well. So this is like a practical scenario. Like we've got some money, we're not going to take all of it out at once, but we're going to start taking some of it out, right? So the amount that we start off with is $1 million. What was the rate? 6% per annum, compounded quarterly. Okay, so we know that's the first thing I noticed. So then I want to know the rates when I have each quarter. So I'll divide that by 4. That's 1.5%. Okay, so that's each quarter. So when I write the decimal out, that will be 1.005. Yep, but not up to that. Oh no, 1.015, thank you. Yeah, not quite up to there yet, but that's important to know. Other information that's important.
80,000.
So the withdrawal, we're doing some withdrawals. 80,000, is that each quarter? Yeah, okay, perfect. So here's the scenario that we've got, right? We've got a scenario where I'm saying, okay, I've got some money. I want to be taking 80,000 out each quarter, but I'm also getting interest on that. And they asked you to do something for part 1. They asked you to show that a sub 2 was equal to, what was the expression? Like that? Is that it? Eva, yeah.
Sorry. So they withdraw 80,000 at the end of every fourth quarter.
At the end of every quarter?
Fourth quarter.
Or every fourth quarter. Good. Okay, that's also important. It is very different. So each fourth quarter, I suppose. Yeah. Okay. So here's the scenario, right? And why this fact here is important is because if you look at this, they have a sub 2, but then this is to the power 8 and this is to the power 4. So that's the first thing to know that I'm like, oh, that's a bit weird, right? How that kind of incorporates into the question is, if you think about it, really, when you've been building them before, we've just been doing like them each month or whatever. And that's because the amount of times that they compounded was the same as their deposits or withdrawals. But here's a way they actually change that, right? They say, all right, it's compounded quarterly, but it's only withdrawn every fourth quarter. So that means that when you're crafting this series, really the only time you care about this is when you make the withdrawal, because that's the only thing that's affecting. Otherwise, you can just think about the interest accumulating over time, right? I saw some people building it month by month and going from there. That's fine, right? But you can just as easily skip that and go to like the first quarter, right? Or the fourth quarter, right? So if we let A sub n be, how should we say this, every fourth quarter, then that means that A1 is going to be, all right, what was the amount that I had? I had $1 million multiplied by 1.015. But remember, it's calculated, the interest is calculated each quarter now, right? So that means how many quarters have passed by the fourth quarter, or it'll just be 4, right? And then how much money am I taking away? I'm withdrawing 80,000, right? So that's what A sub 1 is, right? Just be aware that now in this case, I'm letting A sub n be the amount of like every fourth quarter. And so then you can start to see how this will come about. So that when I want to find A sub 2, what else do I need to consider? So here's A sub 1, here's the fourth quarter. The next time this rolls around, I've got this amount here, A sub 1 again. What do I need to apply to it? The interest, yeah? So the interest, right, because remember, this is the next fourth quarter now. So that's multiplied by 1.15 to the 4. And again, I have my withdrawal, right? So that's 80,000, right? And then you can go ahead and simplify it out. one thing to note is like you're gonna be running a milli nat a lot of times, so you know if you want to let that be like 10 to the 6 or something, I don't know, that might be something that saves you some time. Here we're adding the indices when we multiply them, so that becomes 8, and then here we have this situation. Now, at this point, this is actually the same as this, but especially when they ask you to show something, I always take that one extra step and try and make it look exactly like it's meant to be, yeah? So the only thing that we have to do is we factorize out the 80,000 from this expression here, or the negative 80,000. And I get 1 plus 1.015 to the 4, okay? Any questions about that so far?
Sorry.
Yeah.
So AN is every fourth quarter. So like A1 is the fourth quarter.
Yeah, that's right.
And A2 is the eighth.
Yeah, if you want to think about it like that. So what was the question? It said, yeah, because the question said, show that the account after the withdrawal at the end of the 8th quarter is this amount. And the only reason I'm really doing that is because that's how they've given it to me. They've asked me that, show that the end of the 8th quarter is this. So they've kind of given me a way to create the series. And that's often going to happen. They often want you to create the series in a particular way, and the question will kind of guide you towards that. But you do have to be careful. It might not always be the same each time. Yeah, good question. Okay. Part 2. Maylin, what's part 2 asking? It was like, for how many years? Can the full amount be withdrawn, right? So, when I'm looking at this one, remember how I said that wording is sometimes important? This is one of those situations. Because they're explicitly asking for the full amount here. There's no rounding that we can really do that's gonna make this work either way. It has to be the full amount. So I saw a few different approaches for this. One approach that I saw was, okay, well, if I want the full amount to be withdrawn, I really want to withdraw down to 0. Right? But then when you notice when you get to 0, it might not be exactly 80,000, that last withdrawal. So yeah, you just have to kind of check to make sure that works. The other way that I saw was some people said, okay, why don't I let it be equal to 80,000, the amount left? Then I know I can do one more withdrawal exactly after that, and then that would work as well. Either way would be fine, from what I can tell. I personally let it equal to 0, and then I just checked it after that. Either way though, apart from the letting the variable be a different value, the approach is still the same, right? At this point here, I'm happy for you to go straight to A sub n. Usually I want you to do 3, but I'm happy for you to do it here. A sub n, what's that going to be equal to? It's a bit tricky in this case because if you look at it, these are A sub 2, right? But, I mean, A sub 2, how does that relate to this number? And how does that relate to this number over here? That's kind of the issue that we have. And the thing to go back to is that this is every 4th quarter, right? This expression. So if you think about it, right? Well, if it's every 4th quarter, that's leading you to multiply things by 4, right? Can you see that? Yeah, because if this is every 4th quarter, this value here is just 4 times 2. Well, this value here is just 4 times 1, right? So this is how I'm going to build up the series here. What I'm saying is that then A sub n is equal to 1 million times 1.015 to the power of 4 times n, take away 80,000, and then I'm adding all the terms up until, what am I adding up until? This is a bit different now. It's not 4n though, because remember, this is 4n. What would this guy be here in terms of n? Yeah. Perfect, because if you think about it, you're going 1 less on your 4 times table, right? This is 1 less on the 4 times table. So basically, you're taking 1 less than n, so that's n minus 1, and you're multiplying that by 4. That's the key thing here, okay? That's something that's not like immediately obvious. Right? So there's your expression. Once you've got that, then we can let A sub n equal to 0 or to 80,000, whichever one you wanted. So let A sub n equal to, I'm going to let it equal to 0. I'm going to go back over here. So we've got now 0 is equal to 1 million times 1.015 to the 4n. Take away 80,000 outside of this. Now, at this point here, instead of writing out so many zeros, what I might do is just simplify it out first, right? So I might just divide through by these zeros here. So like literally just to save time, writing out all these zeros. So I'll divide everything by 10,000. So I can cross off 4 zeros from each of these. There we go. That's just to save me time writing. The other thing you'll notice in a moment is that hopefully we've seen, this is like recognizable, this is a series, right? Just be careful though with this one. We want to find 3 things. We want to find A, we want to find R, and we want to find N. What are each of these going to be? A is obvious, that's just one. N and R, be a little careful here because the series looks slightly different. Any thoughts on that one? The R value, it's still like, what do we need to multiply each time to get to the next one, right? But notice it's slightly different here. What is it? Well, what do I multiply this by to get to that guy? To the power 4, right. So be careful you don't miss that to the power 4. That's really important. Yeah. Number of terms, if you think about it, right? If you're multiplying by 4 each time, you can think about this as, the first term, the second, well, actually that's the first term, isn't it? First, second, third, and then going all the way up to n minus 1. So if you think about it, this is going from to the power 1 to the power n minus 1, and we have that other term there still. So the number of terms, that's just n, really. Still n. Okay, so let's put that all together now. Then what I have is this. I've got 0 is equal to 10 times 1.015 to the power 4n. Take away 8 outside of... That should be 1 million actually, shouldn't it? Sorry. So an extra 0 there. Should be 100. And then we have this 8 here. And so our series is going to look like this now. A outside of R to the n minus 1. So 1.015 to the power, so 1.015, that's the rate, to the power n, take away 1, all divided by r minus 1. So remember the r is to the power 4 this time, just be aware of that. Now at this point here, remember, what are we actually trying to find? We're actually trying to find the n value, right? And the issue with the n value right now is that it's kind of locked in between 2 places. It's inside this guy and it's inside this bracket. So if I'm trying to find the n value, what I need to do is I need to create a situation where the n's are together, right? So I need to try and work through this. We looked at a problem last lesson where we sort of evaluated this fraction, so it was a bit nicer. I'm going to do that again here. So I'm going to do 8 divided by this and get that as a numeral. Can someone do that for me? Maybe we leave it as it's like 500, 1/3. Ooh, that's not nice at all. All right, maybe we just leave it as it is. So if I do 8 over, actually I remember what they did in the solutions. They wrote this as like another variable k here. I know that's going to be more confusing, but let's just leave it for now. So that's outside of this, right? So all I've done is I've just like put that over here, so that's more easily identifiable as I'm going to expand in a second, right? Questions so far before I power through this? So I think the hardest part is developing that general series, and then the steps after are the same, okay? So, just to finish it off, I'm going to expand this out. So at this point, 2 things, right? Identify which parts we want to find as the n value. It's this thing and this thing, where we're trying to get n is equal to something. At the end of the day, I want n is equal to something. That's all I want, right? Yeah, so you're right. Thank you, plus. Yeah. Yeah, perfect. These 2 things are the ones we want to bring together. Yep. So all we need to do at this point is that we factorize out these parts. Can you guys see that? All I'm going to do is I'm going to factorize out these parts. So 1.015 to the 4n outside of this plus that. Is that looking all right, Melanie? So the plus is there, right? Is that right? Can anyone see the last few steps I need to take? Question? So that's this multiplied by this? Yeah? Why did I expand, or where did that come from?
No, I know where.
Okay? So remember, the whole idea is I want to get the n by itself, but I can't do that unless I bring them together. That's the key here, right? So at this point here, all I need, can anyone see the final 2 steps I need to take to bring this home? How can I get this by itself? It's in a power. Sorry? Yes, we do, exactly right. But before we log, we need to make sure all the constants are on the other side. What are the constants here? The constants are this is just a number. I didn't write it because it's a nasty decimal, I left it as a fraction. This is a number, and this is a number. So 2 steps we take. Just treat these as numbers if that helps. Just rewrite them as like decimals if that helps, right? But 2 steps, right? We move this to the other side. And then one last step, what's the last step? Well, what's the operation here? They're multiplied, so then we divide, right? And so what you're gonna do is, this is gonna be a number that you put in, and this is something that we want to log. So I'll just write out the values for you. When we log this out, I get ln of, it's about 4.29 or something. And remember your log laws, right? So we bring this out. And then we divide. So really I need to divide by 4 as well. Divide by 4 and divide by this log. Can someone put that in for me? I think you got like 24.46 or something. It's 24.46. So then what you need to do is you say, if you put that in, you're gonna get, you can't go to the 25th one, right? You have to round down in this case. Because that's the last full withdrawal you can make.